talk about water masers in post-AGB evolution and in planetary nebula. So this work is a work of a team. So you can see here from Spain, France, Mexico, Greece. This is yes. So the outline of the talk is the following. I will start talking a little bit about the characteristics of water masers, then the water masers in post-AGB stars, especially the water fountains, then water masers in planetary nebula, a few words on a very special object, this one, and finally the conclusions. So water masers are found in several astronomical objects, in environments of geostar objects in star-forming regions, also in AGNs, and in our case, what is interesting for us, in evolved stars in AGB, post-AGB, and planetary nebula. The physical processes that produce the water masers is a hyperfine transition between these two rotational states, and the excitation of these states under decay is made mainly by shocks, less by infrared radiation. We need very special conditions to pump water masers, a temperature of about 100 Kelvin, the ratio of Flammable losses in the water molecule is this one, and we need also a hydrogen volume density, very specific. So we don't have water masers everywhere, we have them in very special points. The advantage of studying water masers, or masers in general, is that they give us very precise information about the position where they are produced, because we can have, since they are punctual sources, their resolution we can have is better than the nominal resolution of the telescope, the beam. And they give us also the velocity and the proper motion, since they keep moving for several months. So there are very nice studies of proper motions in masers. In particular, the water fountain stars, I think the right today is the right day to talk about this. There are evolved stars that show these water masers with high velocities, so they have of the order of 100 kilometers per second. They were first named by Nickel and Morris, I think it's in 1988, no, not 98. For the first one, it's the best known. The type of objects that are showing these characteristics of high velocity water masers are either late AGB stars, but mainly post-AGB, and as we are going to see, 1 PM for the moment. All the objects are bipolar. Most of them are obscured at visible wavelengths, so they are anonymous objects that weren't known or very studied before, until someone discovered the H2O maser at high velocity. We will see next talk that most of them are massive, and well, for the moment we have 14 classic water fountains, but the number is increasing, so we can ask if it is a very rare phenomenon, or simply we didn't found yet most of these type of objects. Why they are important is because they show the first manifestation of axisymmetric jets. So those jets that we see in planetary nebula, we see these objects how they are being born. And so they are key objects to trace this emission of jets that will shape the planetary nebula. So I present here a tentative classification of water fountains. We can see, so several of them show masers directly on the jet. So this row. several of them show masers at the equatorial outflow, or disk, or torus, or whatever. So this one, and some others doesn't show masers at the equatorial outflow, and they show the masers in the bow shocks. So I put here the number of objects and the name of the objects that we know in each class. And we can think that when a jet is produced, it is going first to produce the water masses along the jet, and later on it will come to the to shock with the circumstellar envelope and finish in that part. So with the masers in the bow shocks. We see that most of the objects are here. They don't show these water masers around the central star, and very few objects are here. These show magnetical correlation also. And I would like to have found here, like, if you see the ages of the jets, I would like to have found these youngest objects and these the jets with more higher ages, but we don't find that. I can't explain exactly why, but I think it is interesting to have more objects here to see if this represents really an evolution. Several examples of this type of objects. So here we can see two jets of masers, water masers, with several masers around the central stars in the intermediate velocities. Here, this is an example of a bow shock. This is another bow shock with masers at the intermediate velocities, and this is another bow shock without masers at intermediate velocities. The driving mechanism of the jets, well, this is not, we don't know how they start, but in this work made by Andrés Pérez Sánchez and collaborators, he will show that this jet is magnetically collimated and it has synchrotron radiation, so at least we know that that exists. We see that some of these jets have precession, so is it a sign of binarity? Maybe, but no binary has ever been detected in these objects. Maybe they are there, but we don't know how to detect them, so it's something interesting to work in also. In the case of planetary nebula, like 10 years ago, we thought that it wasn't possible to find water masers, but since then we have discovered 5 objects showing these masers. They are all bipolar sources. In all cases, the masers are close to the central stars, and they don't have high velocity components except for the object that I will present at the end. 2 of them are optically visible, and 3 of them are completely obscure in the optical, so we only have infrared data when we want to make the image of these objects. So several examples. The first one was K335. The masers in red are in the center. Those are radio images, which we see as a spot there also, masers that have disappeared since these observations. Another one, so we see that they are highly bipolar. Another one here, the masers at the center, in this case showing like a ring around the central star. In this case, we have only several components. So we can try to imagine a possible evolution for this type of objects. So we will start with a standard positivity star that show several water masses around them. The jet will be launched at one moment at the positivity phase, showing this waterfront, and the yellow dots represent the masers. We could have several masers also around the central star. When the central star will become a planetary nebula, we can still have these high velocity offsets, as I will show later, and then the planetary nebula will evolve, and these jets will slow down, so these masers will slow down also, and will finish by having also, only the masers around the central star. Only one thing confirming this is that, as you see, very few objects in the posterior phase show masers around the central star, but all the objects in the planetary nebula phase show the masers around the central star. So it is difficult that they come from here, or maybe the water masers will belong to again in the planetary nebula phase. So last thing, this object, you can see the poster number 17. So it's the first planetary nebula that show this water maser with high velocity. This is an infrared image. This is another infrared image in the J-band. This is the position of the radio continuum and the maser that is aligned with the bipolar form. And here we see a focus on the masers. So we can see there is a jet that could be precessing also, and the spectra of the jet that is very interesting is the strongest maser known in an evolved object. It has 1,600 JASM, something that we have never seen. So my conclusions. So the water maser traces the jets that shapes the planetary nebula. They follow the transition to the planetary nebula phase, and they disappear shortly. That's why we don't find many of them in the planetary nebula phase. And it is important to increase the number of waterfront I know to be able to do statistics about these objects and look for binaries if you know how.
Last ones that you used to show where the water maser emission is 1.5 kilo Jansky.
Yes.
Yes, this flux is really strong compared to the other sources. How do you rule out that the star forming emission? How do you rule out? How do you know it is not a star forming emission?
We have several evidences that it is not. There is not molecular emission in this particular source. There is molecular emission close to the source, but it is associated to a star forming region that is different. The infrared images in the WISE images and Spitzer show neutral sources, so that is not an H2 region. And all the evidence show the Iris two-color diagram and the MS6 two-color diagram is also in the right place to be an evolved object. So we have a lot of evidence that show that it is not a star forming region.
I have two comments and questions. The first one is, it would have been nice if you also incorporated the OH masers, because in some of the objects like 16342, you don't have the pictorial H2O masers, you also have OH masers. And the other thing is that H2O masers might disappear because the H2O has gone onto ice, water ice, on the dust grains. In fact, in 16342 and maybe other objects as well, you actually have direct evidence of water ice in the spectrum of the dust grains.
But in planetary nebula or in posterior stars?
No, water ice is more in many objects, evolved objects. I'm saying that the disappearance of H2O in the equatorial plane might be a result of the water going on to ice matters and dusty grains.
Okay, thank you.
More comments, questions?
Yeah, okay.
This 500 nebulae that you talked about, any of the observations of this one were made in full polarization mode?
No. We don't, only in areas 15, 103, so the last one, but we didn't found any polarization in the components.
But very good.
Only that one, not the rest.
Yes.
For an object in a bottom maze, it needs to be oxygen rich. And so you're missing objects that are similar in all respects, but just have to be carbon rich. So should CNL 618 be one of the confounders, just next one, but there's everything else that it needs to be one of the class?
Sorry?
CNL 618, it has the right velocity, the right shape. It seems to have everything that you need for the bottom maze, except the bottom maze.
Yeah, yes, we are missing those objects. That's, I mean, if we study water mazers, we can't do, it is not a full explanation of everything, but it's just to see what can we learn from water mazers. There are objects as that one that, yes, they could be, but they are not.